name is Spencer Martin, and this is evidence for black holes. So this is the first ever image we've had of a black hole. Up until this point, all images of black holes were illustrations and what we really hypothesized and thought that a black hole would look like. This was made from a computer algorithm, data, and images that we took with satellites to create this one singular image of what we know a black hole looks like. Since it's the first picture that was ever really put in the public eye. People looked at it on the news, it was on the internet, Twitter, everything. The black hole is a former star, usually about 3 times the size of our star, the sun, that collapses into a single point known as a singularity with infinite density. We can know that black holes exist and have evidence for them by observing them on Earth, seeing the event horizon, and the X-rays that they produce. So they're observed on Earth by seeing that stars orbit, quote unquote, nothing in distant galaxies. We know that nothing now is the black hole and its event horizon in which light cannot escape. The light falls in and produces the X-rays that produce light that we see around it that are observable from Earth with telescopes, and scientists can look at that and judge how big they are and how far they are away. We can also tell that in a binary system where 2 stars orbit around each other, that when one of them collapses and turns into a black hole, that they will rotate around each other the same way as if they were both planets because they have the same mass and the same gravitational force. So the X-rays. The X-rays are caused by the protons and neutrons that funnel around and swirl into the black hole itself. They create light that we can observe here on Earth that rotates around the black hole and creates this big swirly, almost hurricane-looking thing that we can see. And the X-rays are projected out into the galaxy. They can produce, when they collide, they produce the X-rays that come to Earth. And these can be used to calculate the mass because we know how fast they're going and what kind of energy they can produce. So the event horizon is the distance from the center to the black hole to the edge of the black hole, where the speed of light is the escape velocity. So light can't escape because nothing goes faster than the speed of light. The more massive a black hole is, the further out its event horizon will be because it is more massive and has a bigger gravitational pull. This is why we can observe that stars orbit nothing, because since they go around the event horizon where no light can escape, we can't see anything physically. It's just a black spot in space where we see things orbit around it. But since it has gravity, has mass, it orbits around it the same way it would orbit around a planet or a different star. So black holes are important because it helps us understand our universe that we live in. It's very important to know why we're here, why things happen the way they are, because before the new picture that just came out, really we didn't 100% know why everything happened. It was just a theory. And before then, we were looking into the cosmos and seeing stars going around basically nothing, and we were thinking why, because it doesn't make any sense from our point of view, where we see things like the moon going around the Earth, or the Earth going around the sun, or the sun, or our galaxy going around in our bigger galaxy. So it just didn't make any sense. But now that we can see what happens, more people believe in them, obviously, because seeing is believing. And it's one of the most important discoveries that has ever been made in science. And it's very exciting to be on the cusp of such an interesting and important scientific discovery, because we're really just learning the basics. We don't know everything there is to know about a black hole, and it'll be very exciting in the next few years to see where it takes us. Thank you very much.